All right, so today we're talking Pythagorean theorem. So today I can statements. I can use the Pythagorean theorem and I can use the converse of the Pythagorean theorem. Um, Pythagorean theorem is something that's really cool, really helpful. You can use it 100 different ways. That's why I taught it to you guys earlier in the year, because it's a beneficial skill to have as you move through math. But today is the actual lesson on it, the real deal, 100% lesson on it. So first things first, Pythagorean triples. Pythagorean triple is a group of positive integers that can satisfy the equation a squared plus b squared equals c squared. And what that means essentially is a, b, and c all have to be integers, meaning your positive counting numbers. All right, Pythagorean theorem. Old Pythagoras, he sacrificed a hecatomb of cattle for us to be able to use this, so we gotta be grateful. And what Pythagorean theorem says is that if you have a right triangle, then the two legs of the right triangle, A and B, if you square them, then they are going to equal c squared, or the hypotenuse squared. So two short sides squared, a squared plus b squared equals the longest side, c squared. This is great for finding your missing lengths. You can use it to calculate distance. You can use it to calculate drop. You can use it to calculate rise, slope, so on and so forth. Amazing tool. The one thing I do want to highlight in right triangles, the hypotenuse is always the longest side. You can always tell it's the longest side because it's going to be opposite of this 90-degree angle. That's just a quick way to tell that. So let's find x. Well, first things first, we know a squared plus b squared equals c squared. Why? Because Pythagoras said so, and Pythagoras knows all. So first things first, I want to label these just as we kind of start to get into it. So I know my x side here, that's opposite the 90-degree angle. That's going to be my c side. As for which one of these we label a and b, doesn't matter. We could switch them, doesn't matter the order. A squared plus b squared equals c squared. B squared plus a squared also equals c squared. So getting down to the brass tacks now, we just got to do a little substitution, plug in our values, and solve. So a is 4, so 4 squared plus b is 7, so 7 squared is going to equal unknown, or our c squared. 4 squared is 16, 7 squared is 49, c squared is c squared. So 16 plus 49 is going to equal 50, 65. 65 equals c squared. So now we need to take the square root of both sides. Square root of c squared is going to be c, and then square root of 65 is going to be decimal sadness. It's going to be like 8 point something. Square root 65, 8.1. We'll just call it 8.1. Now, as far as writing your answers here, so x equals 8.1 or x equals about 8.1, you can say x equals 8.1 doing that square root rounding, or if you'd rather just say, yeah, x equals root 65, as long as that's not a perfect square. So if you're going to get a decimal as your final answer, you can just leave it in the square root form. That's totally acceptable as well. All right. So let's look at another example. So right here I see 12 is going to be my c because it is opposite that 90-degree angle. I know a squared plus b squared equals c squared. Now I'm just going to go ahead and label a and b. Once again, don't feel like you have to do that. It's just so we can see it now since it's still new to us. And then 12 is c. So I'm going to do a little substitution. A is 8, so 8 squared plus, we don't know b, so I'm going to say b squared equals c squared. C is 12, so 12 squared. Now we do our squaring, so 64 plus b squared equals 144. Now we do a little subtracty subtract, which would be b squared equals 80. Now when we do the square root of both sides, we're going to get like 8.9 or something on the right-hand side, because it's just short of square root of 81, which would, of course, be 9. Yeah, so 8.94. So B is going to equal 8.9. About 8.9. Once again, if you wanted to, you could leave it as B equals square root 80. That would be totally acceptable as well. Dealer's choice. All right, so these would be the two that you would give a go on your own. I'm just going to solve them real quick so that you guys can have the answers for those of you watching this online. B square root 30, square root 39. Oh, these tricky people. So 144 minus 36. All right, so we got square root 108 is our answer here. Now, what they have decided to do is factor, which not a big fan of. Don't like when they do that to me. So what I'm going to do is I'm going to make this square root 4 times, what would that be? 27? Correct? Am I wrong? 108 divided by 4, 27. 4 times 27, 20. Why did I write 29? I'm thinking one step ahead, I guess. Back. 4 times 27. I'm going to factor out a 9 now. So 4 times 9 times 3. So I can take out my 4 because square root 4 is 2. So I can say 2 root 9 times 3. I can take out the 9 because square root of 9 is 3. So I'm going to say 2 times 3, which is 6. 6 root 3. So B. Lovely. Okay, Pythagorean triples. These are integers that will, are sets of 3 integers that satisfy the Pythagorean theorem. So there are essentially 4 groups of these, if you will, which is this top grayed out row. And those are kind of the important ones, if you will. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Any of these other ones that fall below in each column, those are just found by multiplying by our originals, the OG Pythagorean triples. So if you look going down here, they just timesed everything by 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Likewise, in this next one, multiplied everything by 2, and they follow that pattern all the way down, multiplying by 2, then 3, and then they give you the algebraic example. Pythagorean triples aren't wildly important. They can be helpful if you memorize them, then you can use those to help you solve problems quicker. However, if you don't know them, you can still do Pythagorean theorem, so it's really not that big of a deal. If you wanted to write these down as just a quick reference, it's kind of a cheater's way to do it. I say cheater's way positively. I mean, just a quick way to do it. You can, but personally, I don't memorize all these. They say, use a Pythagorean triple to find x. Explain your reasoning. So, personally, I see the Pythagorean triple here. I see that 13 times 2 is 26. 12 times 2 is 24. So I know this other one has to be 5 times 2, which would be 10. But let's pretend I didn't know that. So see, using Pythagorean triples, I know x equals 10. Just right off the bat, just like that. Now, if I didn't know that, I would say 26 a squared plus b squared equals c squared. C squared is 26 squared equals 24 squared plus b squared. So then we would have to work these out, and we would do 26 squared minus 24 squared, which would be 100. So we would have b squared equals 100. We would take the square root of each side, and look at that, b equals 10. So it took me an extra 20 seconds to do it the long way. Got the same answer either way. So it really is dealer's choice if you want to learn those or not. Once again, we're using that same 5, 12, 13 here. They're just multiplying it by 3 this time. So it's going to be 15. Continuing on. So we have a 20-foot ladder that is placed against a building to reach a window that is 16 feet off the ground. How many feet away from the building is the bottom of the ladder? So this one, I don't know the Pythagorean triple off the top of my head. So for this one, I would say x squared plus 16 squared equals 20 squared. So 20 squared minus 16 squared is going to be 144. So x squared equals 144. We have to take the square root of both sides, which would, of course, leave us with x is 12. Lovely. 10-foot ladder is placed against the bottom of a building. So 10-foot ladder, that's my 10-foot ladder. The base of the ladder is 6 feet from the wall. Let's pretend this triangle is even remotely close to accurate. It's a slanted building, apparently. How high does the ladder reach on the building? So 10-foot ladder, 6 feet away from the wall, unknown. And I'm assuming the building is square, meaning it's the 90-degree angle. So a squared plus b squared equals c squared. 6 squared plus b squared equals 10 squared. 10 squared is 100. 100 minus 36 would be 64. So b squared equals 64. Square root both sides. b equals 8. Lovely. Continuing on. Now we get to the converse. So what the converse of the Pythagorean theorem says is that if a squared plus b squared equals c squared, then you're looking at a right triangle. Whoa, crazy, wild stuff. Now, this does parlay into a couple different things that are kind of more important to me, and that is these Pythagorean inequality theorems. While these are less commonly used, you will probably see them on a test, a quiz, maybe even a standardized test at some point. So what these say essentially is that we know a squared plus b squared equals c squared. That equals a right triangle. Now, if a squared plus b squared is greater than c squared, then we have an acute triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. So these are just two inequalities that we can use to determine what type of triangle we're looking at. And the important thing here to remember is that c is always the longest side. The other thing we have to remember as we move through this is that any two sides, so our two smallest sides, have to be bigger than that third side. So we need to remember a plus b has to be bigger than c at all times for this to be a triangle. If this is not true, then we do not have a triangle. If a plus b is not bigger than c, we do not have a triangle. The two smallest sides have to be bigger than the third side. So this should always be our first check. Okay, determine whether 9, 12, 15 can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Right off the bat, I know this is a Pythagorean triple, but we'll continue on the way they want us to anyway. So first off, 9 plus 12 is 21. 21 is bigger than 15. Boom. 9 plus 12 is bigger than 15. That checks out. This can be a triangle. Next thing, a squared plus b squared equals c squared. A squared is 9. So 9 squared plus 12 squared equals 15 squared. And I'm using an equal sign, but we're going to change that sign at some point here. So 9 squared plus 12 squared equals 225. 225 equals 15 squared, which is also 225. Since those do equal, we have a right triangle. Now, I don't remember if there's another. Yeah, there is another one. Perfect. So that's not the one I'm looking for, though. Oh, no, this will work, actually. So first things first, a plus b has to be greater than c. 10 plus 11 is 21. 21 is bigger than 13. Check that. This is a triangle. Next thing, a squared plus b squared equals c squared. A squared is 10, so 10 squared plus 11 squared equals 13 squared. So 10 squared plus 11 squared is going to be 221. 13 squared is going to be 169. But hang on, those don't equal. Well, I just used an equal sign because it's what makes me comfortable to keep these separated. If you wanted to, you could say, no, I don't want to use an equal sign. I want to use a rectangle to show I need to fill this in at some point. That's totally fine. So a squared plus b squared in this case are bigger than c squared. And since they are bigger than c squared, if we go back and we look at this, a squared plus b squared is greater than c squared. Okay, that means it's an acute triangle. So let's go back to that problem we were working on. And we would say this is an acute triangle. So if I were you, I would maybe write this in my notes. I would say a squared plus b squared is greater than c squared. Acute. A squared plus b squared less than c squared. Obtuse. And then you should already have a squared plus b squared equals c squared etched on your brain or in your notes. That would be a right triangle. Lovely. Continuing on. These you would solve on your own, but we'll do them together here on the video. So 7 plus 8 would be 15. 15 is bigger than 14. All is happy in the world. 8 squared plus 7 squared equals 113. 113 is smaller than 14 squared, meaning that this is an obtuse. Continuing on, indicate whether these can be a triangle. 14 plus 18 is 32. 32 is not bigger than 33, therefore this is not a triangle.